Hello class. This video we're going to go into a little bit more details about objects, and I'm going to build an example object to demonstrate some of the sections of chapter 9 or class 8 in our textbook. So we're going to start out with creating a bank account object where we're going to be able to demonstrate several properties and several concepts that relate to objects. So first thing we want to do is, well, I started up our test environment, and I'm going to create a new .java file, bank account.java, and we'll open it up, and we're going to start typing in our code for bank account. And we're just going to keep it simple, at least at the beginning, and we'll probably expand on it as we go. But we need to start with the standard public class bank account and give it the curly brackets. So now we have our class, somewhat created. It's really not doing anything. First, let's create our fields. And the first fields we want to create, we'll keep it simple. We're going to make everything private. Private string. We'll give it a name. Every account needs a name. We'll give it an account type, private. Let's give it a integer as an account type. And we'll assign those values. This way we can have some room to expand, and we'll call it 0 for checking, 1 for savings. And let's give it, a balance. Balance. And we'll give that a double because we're going to track dollars and cents here. As with any good program, we want to make sure that we initialize our variables. So it's always good practice to initialize our variables before we do anything. Even in an object or a class definition where we create an object, we should give it some default value. No name. And we can set the account type to -1, and maybe -1 would indicate not defined, and we can declare that here. And what's a good starting balance? Well, I guess 0 is always a good starting balance. I'd always like to be higher, but 0, you have to start somewhere. So there's our basic list of fields. We may add some more as we go on, but let's start with that. So now that we have our fields created, we have our fields have their initial values. Let's follow some good practice and set up a getter and a setter or for the name, because we're going to want to be able to set the name. So we'll do our public void set name, and it's going to take a parameter of a string because we need to have a name as a string. And we'll do my standard p underscore for parameter. And then we can do our name equals p underscore name. So we have set our name, and we'll also need a getter, public string. We want to return a value this time, get name. And we don't need any parameters to that one because we're just going to return the name. And we'll just return name. So very basic, very simple function. Functions created to set two fields. Let's see if we can put it into our lab program. And we'll create a new bank account class variable. So we'll give it the type. Bank, can't type the capital B, bank account. We'll call it my checking equals new bank account. And there, we've created our bank account. And we can do the set name with my checking dot set name, and we'll put my name in there. And just to confirm it, we'll print it back with a simple print statement. And actually, what I'll do, I'll take this line of code here, and I'll put it right after the definition, so we can see that it should print no name first, and then it should print my name second. So let's run that, and cannot find symbol. What did I do wrong? Oh, I can't spell. I need a account has 2 C's in it. There we go. So there we go. So it printed no name first because I didn't set a name initially, and I set the name, and then I did a get, and I got a name. So yeah, we did all see all that last week, and that's pretty straightforward. But one thing you'll note is that what's missing in this class definition? Well, we have a set, we have a get, we have some fields, but we don't have a constructor. We did not create a constructor. So if we leave out a constructor definition, Java will implicitly create one for us, and it'll just create an object with whatever the default values are of the class fields, which it did. And we saw that when we went and printed the get name. Now, while that does work, probably not your best programming practice to leave it up to the language to determine how to create an object. I think we want to probably define that ourselves. So let's go in and let's create our own constructor. And we can now, again, use the class fields, and we can set the values here. And I will quickly do all these. Account type equals -1, and account balance equals 0.0. Now, yes, these are the same exact values that are in here, and we can also, instead of defining them there, we can define them in the default constructor. So if I run this, and I would expect to see the same output, but I am not because I can't spell balance, B-A-L-A-N-C-E. Let's try that again, and there. Worked exactly the same way, and we've got the same values in our output. So we have our default constructor, we are able to create our object, we are able to set the name and get the name, and that is all well and good. What if I wanted to create an account, bank account object, and I already knew the person's name and I just wanted to create it right away? Well, we can do that. 2 ways we can do it. We can create the default one and then use a getter, or I'm sorry, a setter, and set the name. Or we can create another constructor. So you can have multiple constructors. And in this version of the constructor, we'll put in the name, and we'll set the name. Name equals P underscore name. Oops, I think curly square bracket. P underscore name. Now, we could also set these default values, but we don't necessarily need to because we've already done that up here. So let's try to write a little piece of code, and instead of a checking account, why don't I create a savings account for somebody else? Bank account my savings equals new bank account, and this time I'm going to give it a name, John Doe. And then I will do a print statement. My savings.getName. So now I'm creating a bank account and I'm initially giving it a name. I don't need the getter, the setter. I don't need to give it the account type and balance. I probably should at some point, but for now, for this demonstration, we're just going to see if it can create it and print out the name for the My Savings account as John Doe, pending any typos. Nope, and there it is, printed John Doe. So we were able to create this object, the My Savings object, using a different constructor with a predefined parameter. Well, and I guess the last example we'd want to look at then is to create a fully constructed constructor with all parameters. And we'll do account type, that's an integer. And we'll do a double of p underscore account balance. And you don't have to use this p underscore mentality like I use. It works for me. Feel free to use something more descriptive for yourselves, but it helps me keep it organized. So now we can do name equals p name, account type, too many C's, account type equals p underscore account type, account balance equals p underscore account balance. Okay, so let's create our third object, bank account, another checking account equals new bank account, and we'll give it a name. Let's see, Jane Smith. She's going to get a savings account, and oh, I said checking, so checking account, and she'll start with $100. And there we have our account created, and we're going to use this new version of the constructor, this fully formed version, so we can populate all the values at the same time. And again, I'll demonstrate by doing system.out.println another checking.getName. And we should see it print Jane Smith, and it did. So with this example, you could see we have a default constructor, we have a constructor with one parameter, we have a constructor with 3 parameters, and you can make more. You can make more combinations. You can have a name and account type, no balance. You can have a name and a balance and no account type, and whatever suits your needs for whatever type of problem you're trying to solve. So that's neat, and this works because it has something called constructor overloading, in another sense method overloading, where you can create different methods. Well, it's actually the same method with different signatures. So you see this one has no signature, this one has a signature of a single string parameter, and this one has a signature of a single string parameter, an integer parameter, and a double parameter. So you can define as many different combinations of those as you need. You just need to be aware of the requirements of your application so you can build out what you need. In our particular case, it does kind of make sense to create an account with just a name. Maybe they don't know the balance yet, or they don't have a balance yet. You're just initially creating an account. Or maybe they want to start an account with a balance immediately and deposit some cash. So you can do it that way as well. And the last thing I wanted to point out about constructors for now is you'll note that when we define a constructor, it does not have a return type. So constructors don't have return types. They don't even use the void return type. They are understood to return the actual object itself, so you don't need to provide that return type. Okay, so we have created 3 different accounts for 3 different people, and we know that because we can look at our code quickly and easily and determine that. However, it would be nice to be able to keep track of that in some kind of variable. Now, how could we do that? Well, in our main program, we certainly could create a variable, and we could certainly increase a counter and then interrogate that counter, and that's fine. But maybe a better way would be to keep track of it in the actual class itself. Since we know how many objects we've created, let's put a counter in here. So let's start out with private int counter equals 0. Now, the first thing you'll thinking of is, well, that would create a counter for every object, and that is true. So that's not exactly what we want. We want to be able to create a variable that is common to every object, but defined in the class, and we can do that by creating what they call a static field. And a static field is a member of the class and shared among every object. So, slightly different syntax, public static int. And this is where we're going to create our initial counter that lives in every object. And we're going to be able to use that to keep track of the number of bank accounts we've created. And we'll be able to reference that static field not only by not by a getter or a setter, but by simply accessing it with a dot notation. So we can create a print statement, and we're going to call it, well, we could use any of the objects we want. Let's start with the first one, my checking.counter. And we're going to print out a value. And it printed a 0. Not only is it a 0 because we initialized it to a 0, but because we didn't do anything with it. So maybe we should increase that counter every time we create an object. So we can certainly do that. Another reason why you don't want to rely on the default constructor, and you always want to create one, you might not be able to do this. So we can just do simply counter plus plus. And since we have multiple constructors, we should do it in each one to make sure we don't miss any. And now, since I'm printing at the end, I would expect my 0 now to become a 3. And it is. So my checking is the first one we created. And if I had put this print statement, and I think I will do that, underneath here, it'll print a 1 first. And there it did. So you can see, regardless of the object that it is referencing, that static field, or that class field, class variable, whatever you want to call it, it's getting the value that is defined in the class, not the object. So even though each object is updating its value, the value can be accessed from any of them. So at any point in time, we can look at any bank account and determine how many bank accounts we have created. Now, this might be good for something along the lines of maybe a customer number, and maybe we can do that. In fact, why don't we do that? Public static int customer number equals, start out with 0, and we can do customer number equals customer number plus, we could add 100, and we could do some other things, other kind of math, whatever you want to do for your customer number, but you can see it's the same kind of idea. And we'll know what our customer number is too, and maybe that's good if you want to put this into a database and have customer IDs instead of just having names and numbers. And we can print out a customer number. And let's use my savings this time. And we'll run it again. There it is, customer number 300. Now, we need to be careful of this because this is not only just going to update the customer number, it's going to change everybody's customer number. So we really don't want to use it for the person's individual customer number. We want to use it as the next customer number, meaning that whatever the next customer is, they're going to get whatever the prior customer's number was plus some other value. So we need to do a little more math here. So let's call this next customer number equals, and we'll start it out as 1,000, and you'll see the difference here. So we're going to need a private for each object. It's going to have its own customer number, right? This will make a little more sense in a second. Customer number equals, what should it equal? It should equal the next customer number. So this gives us the next customer number, which we starting out as 1,000. So the first one should get 1,000. So then we can do, instead of over here, customer number equals customer number plus 100. We can do next customer equals next customer plus 100. Now, we're increasing the customer number each time, and we're giving it our current customer is equal to the next customer number. So the customer number for this individual account gets whatever the next one is, and then we increase the next one for whichever account we create next. So we're going to need this everywhere. Oops, clean up the tabs. Delete the duplicate line. And if we go back to our main program and give it a run, and we give it a run, there we go, and we have a issue because I need to have, I can't reference customer number anymore because I made customer number a private field of each object, so I would need a getter for that. But I can reference next customer number, so let's just take a look at that for a second. And we'll run it. And the next customer number is 1,300. So 1,000 was the first, 1,100 the second, 1,200 the third, 1,300 is next. So that makes sense. But let's do a getter to return the account number, just to confirm everything. Public int get customer number, return customer number, just a simple getter, nothing fancy. And for our first account here, we will do system.out.println my checking get customer number, and you'll see that at this point our next customer number should be 1,000, and there it is. And then John Doe would be 1,100, Jane Smith would be 1,200, and our next customer, whoever that would be, would get number 1,300. So you could see now we can have the ability to not only track fields for each object, we have the ability to track fields for each class. And that could have various uses depending on what your application is. In our particular case, we want to keep track of the number of customers, the number of accounts, their account, and be able to assign them a new account number without having to look up whoever the last one was and doing some logic or look up in a database. This way we have easy access to whatever the next customer number is. Okay, one more topic for today. But first, let's do a little bit of cleanup in our lab program. We don't need all these examples currently, but first I want to save all these for you in a different spot. So give me 1 second to do that. Okay, that's done. So now, excuse me, let's take a look at cleaning up a little bit. We're going to stick with just one account for now. So we're going to get rid of all this other stuff. We're going to stick with just the initial checking account. And we'll even leave the print statements in for now. They're fine. I want to look at this constructor when I go to create an account. And I want to take a look at how we are calling it with different parameters. You'll notice that I put in the p_name, and we're going to take, particularly we're going to look at this set name, because that's the one we're referencing over here on line 12, set name. What if I just wanted to call it name? And I wanted to use just name here. So my parameter is name, my object, or my object variable is also name, right? That's what we named it here. Do you think this could be confusing? And if we run this, will it get confused? No, it kind of figured it out. And Java has the keyword called this, THIS, this. And this allows us to explicitly tell the compiler that this is referring to the object itself that we just created. So we're referencing the object inside the object. So this allows us to use with more specificity of what variable we want to use to avoid any confusion. And it's very good when you have parameters and variables that have the same name. Again, since we have control over that, we can be a little more careful of it and not have to worry about that. But even if we do that, and we change the assignment variable to p_name, and run our main program, we still get the same output. It still works. So this allows us to reference the variables of an object inside an object. And it does have some other uses with the constructor, for example. And we can use it as a kind of a function, and maybe we want to use an example here. We can use something called this, and we can set up a way to invoke the constructor with, and I'm going to put in account, change my name here just a little bit, and I'm going to give it 1, and I'm going to give it $100. So now I am using an overloaded constructor. Since I have multiple constructors, I'm having call this one, I'm having it call this constructor. So I'm having it reference this object and use these parameters. So now I can have my multiple signatures referring to, maybe we want to call it the primary constructor. I don't know if that's a good term, but the constructor takes all the parameters so we can set what we want. Oops. I'm going to run it for the main program. And we have to fix our little error here. And I need to take this piece out because we don't need it. So this must be the first call to a statement in a constructor. So we're going to set it up. And you could see I was able to build my object the way we wanted it to look. And I have my new information created. So you could see that this keyword does have some uses. It does have the ability to reference object variables from inside the object itself by explicitly defining what it is. So just keep that in mind when you, if you get some weird issues, you may want to think about using this to very specifically call what you want the variables to be assigned. Okay, I think that wraps it up for now. There is another section in our book called Objects and References, which talks about memory and memory locations and such. I'm going to save that conversation for a future chapter where we get into well, UML diagrams next, but after that, memory management. So we'll talk about memory and the Java memory structure, and objects and variables will make a little more sense in there. So we're going to save it for that. Anyway, that's it for now. Follow up tomorrow with another video regarding doing a full example from one of the lab assignments, and we'll wrap it up for now. That's it. Have a good day, and we'll see you next time.